Hi dear students, let's see this question that came in JEE Advance, Paper 1, Physics in the year 2019. The question was from the topic of optics, and this was on the marking scheme of multiple choice correct. This was based precisely from the topic of lenses, and this was one of the better questions in paper 2. Some of the students found difficulty in this, and hence they left out this question. Also, many students adopted differentiation method and ended up doing it wrong. So we will see why differentiation method is wrong in this question and what should be the correct way to see this. So basically what is happening over here, there is a lens which if we create by this convex lens is of same radii of curvature, that means it's an equiconvex lens. When we use a common refractive index, like that means if we use a single refractive index to create the whole lens which is of value n, then the focal length is f. But if we use n1 if we use n for the left half and slightly different refractive index n plus delta n for the second half, okay, so in that case focal length changes by amount delta f. Further, the change in the value of delta n for the second half has been given much less than n minus 1, and value of n lies between 1 and 2. So we have to choose the options. Okay. Now, first thing, let's see. If n lies between 1 and 2, that means n minus 1 will lie between 0 and 1. And delta n is much less than n minus 1. That means delta n is much less than 0 and 1. Therefore, we can say that the change in the n is very small for the second half. Now let's start solving this question. So basically, this is our lens, right? So first, if it is made up of uniform refractive index n, let us say, so in that case we can say that 1 by f will come out to be n minus 1 into 1 by r plus 1 by r, so that will be equals to 2 by r, 2 by r, right? 1 by r1 plus 1 by r2, and r2 is negative, so we will put one more minus sign, so we will get 2 by r, correct? Now, from here, if this second half is actually made up of n plus delta n, then we can treat it as a combination of two lenses, where first lens is, let's say, f1 and second lens is f2. The focal length of the first lens f1 hai, and the focal length of second lens is f2. So in this case, f will be 1 by f equivalent will be 1 by f1 plus 1 by f2, right? Now what will be value of f1? This will behave as a plano convex lens of refractive index n, so it will become n minus 1 into 1 by r minus 1 by infinity, because this surface is of infinite focal length, radius, plus for the second the refractive index has become n plus delta n, so we will write n plus delta n minus 1, and this will become 1 by 1 by r1 is infinity, so that will become 0, 0, minus 1 by r2. R2 is actually minus r, right? So that will become like this. Okay. Now some of the students, they have issue, like they feel as if this lens, if you remember, this formula can be applied only if a lens is present in a uniform medium. That means on both sides the medium should be same. Now, they might feel, some of you might feel that this lens, left lens के left side में तो air है, but on the right side we have got lens, another lens. So how am I applying this formula? In reality, if you think, देखो मैं next slide पे दिखाता हूँ. If you think that ये जो lens है left वाला, इस type की situation है right now, okay, and we are bringing these two lenses very close to each other, very close to each other, such that eventually what we see is like this. Basically what I'm trying to say, can we treat it, तुम ऐसा समझो कि यहाँ पे भी कुछ नहीं है. Now you have kept one lens, so can we say that this lens is in air? Yes, lens 1 is in air. Now you bring lens 2 in air. Now you keep lens 2 in air and bring it very close. So we can feel as if there is a slight molecules, like बहुत ही thin layer of air present है one और two के बीच में, but it is not visible to us. So basically one और two बहुत ही पास रखे हुए हैं, दोनों air में हैं. यू कैन थिंक भाई दो आदमी बहुत पास खड़े दोनों एयर में, लाइक दैट. ओके, तो so basically we can apply this formula, and hence what does this become? This becomes, uh, if you see, this will become n plus n, 1 by r तो common आ जाएगा, n plus n, 2n minus 2 plus delta n. So 2n minus 2 plus delta n into 1 by r. ठीक है. Now this 2n minus 2 into 1 by r will become 1 by f. करेक्ट. ये 2 इसके साथ मल्टीप्लाई हो जाएगा तो n minus 1 into 2 by r will become 1 by f. So this will become 1 by f, and we will be left with delta n by r. This is actually 1 upon f equivalent, right? Now if we manipulate this, 1 upon f equivalent minus 1 upon f is equals to delta n by r. 1 by r ko we can write from here 1 upon f into 2 into n minus 1. Okay, and what do we get here? Now f equivalent can be written as f plus delta f. Okay, f equivalent was the equivalent focal length of this. So basically what this can be written as original f plus any change that has happened in f. Okay, so I am writing this as f plus delta f. Make sense? Now if you take the LCM, so in the numerator you will get minus delta f divided by f into f plus delta f. This will become delta n upon 2f into n minus 1. Okay, so f and f will be gone. From here what do we get? Minus delta f upon f plus delta f is equals to delta n upon 2 into n minus 1, right? If you see this relation, we know that delta n is a very small quantity. We have already talked about that in the starting, and hence can we say that delta f will also be, right, RHS is very very small, and hence LHS must be very very small, which implies delta f is also a very very small quantity. Okay, so it will not be a crime to write this as minus delta f upon f, because in presence of f we can ignore delta f. So this will be delta n upon 2 into n minus 1, right? Now we are ready for some of the options. If you go to option number C, okay, if we, okay, yeah, let's start with option number C. Option A I think is very very easy to find. If delta n by n is less than 0, delta f by f is greater than 0. Okay, so this of course is right, because you can see both of them have a negative sign. If delta f is negative, then delta n will be positive. It is clear from this what we are getting. So of course if this is negative, then one of them has to be negative and one of them has to be positive. So option A is definitely correct. Okay, let's talk about option C now. It is saying delta f by f is less than delta n by n. Okay, so what I'm going to do, I'm going to put the, let's check if this option is right or not. Okay, let's assume this is correct. So this delta f by f less than delta n by n implies delta f by f modulus less than delta n by n. This implies, now I can put the value of delta f by f from here. So this will become minus delta n upon 2 into n minus 1 inside the modulus. That should be less than delta n by n. That means if we have to check for this, that means it is equivalent of checking for this. Now inside the modulus there is no significance of negative sign, so you can ignore negative, and delta n will cancel out. So this will become 2n minus 1 less than 1 upon n. Modulus I have removed because already I know that n is greater than 1. So now this means that 2n minus 2 will be greater than n, because I have taken reciprocal, so sign of equality will change. So this will become n must be greater than 2. So if n is greater than 2, then only this equality will be, or inequality will be, correct. But if you see in the question, n was given between 1 and 2, and hence this inequality is wrong. Therefore we can say that option C is wrong, right? For option B, it is very simple. Just use this relation. Okay, let me write this again. Delta f upon f is equals to delta n upon 2 into n minus 1 with a negative sign. So if you put the value of n equals to 1.5, f equals to 0.2, delta n equals to 10 to the power minus 3. Okay, so what do we get? Delta f is equals to, delta n was how much? 1 point, delta n was 10 to the power minus 3. 10 to the power minus 3 into f was 0.2, that means 20, I am putting in meters, and n was 1.5, I guess. Yes, so this will become 0.5, right? So this becomes denominator becomes 1, so this becomes, so let's convert this into centimeters itself. So this is 20 centimeters. Okay, so this becomes 0.02 centimeter delta f, and it will be a negative value, but in the question we are being asked the modulus value, and hence we can say that modulus of delta f will be plus 0.02 centimeters. If you look in the options, they are saying to round off to second decimal place. But if you see, I was I did not round off. I actually got 0.02. What might be the reason behind this? The reason is that exact relation is this, but I have used an approximate relation. You can also do the calculations from this relation. As I said, in this case, I have ignored delta f in presence of f. But if you use this relation, calculation will become slightly difficult. But you will see that delta f will become 0.02 something something. So that when rounded off will again become 0.02, and hence that, so this also shows you that making this assumption was reasonable enough, because when you round off to second place of decimal by this exact formula, then also you're going to get the same answer. So this was also one more evidence that this assumption is absolutely fine, right? One more option is left. Delta f, the relation between delta f by f and delta n by n remains unchanged if both the convex surfaces are replaced by concave surfaces of same radii of curvature. This is also correct. Option B was also correct, by the way, because we found the same value. So yes, option D is also correct. Why? Because if you see, this relation is independent of the value of r. There is no feature like r is not coming over here. So this is correct. If you want a more detailed explanation, then let us see why is this coming independent of r. Basically, if we would have used concave lenses, please follow what I'm saying. If we would have used concave lens, then here we would have gotten minus r, correct? Are you for because 1 by r1 plus 1 by r2, and r1 is negative and r2 is positive. So both, like 1 by r1 minus 1 by r2, r1 is negative and r2 is positive. So overall this quantity would have become negative, right? So I can say that this would have become minus, right? So here this would have become minus, and this also would have become minus, right? So here you would have gotten minus, here would have gotten minus, right? Now basically so basically here we would have got a minus sign. I hope you're getting minus, minus, minus. Okay, you would have gotten minus, minus everywhere. Now this n minus 1 into minus 1 by r would have been replaced by 1 by f. So this whole thing would have become 1 by f with a minus sign, and here here minus r would have been present. Minus r would have been present. Now 1 by minus r again would have been replaced by this whole thing, है ना? माइनस 1 बाई आर की वैल्यू यहाँ से अपन डाल सकते हैं. तो कैन यू फील दैट वी वुड हैव गॉटन एग्जैक्टली दिस रिलेशन, एग्जैक्टली ये रिलेशन आता, सारे माइनस हट जाते. कैन यू फील दिस? डू दिस ऑन योर ओन, यू विल अंडरस्टैंड व्हाट आई एम सेइंग. ये सारे माइनस गायब हो जाएंगे, यू विल गेट एग्जैक्टली दिस रिलेशन, एंड हेंस सेम थिंग विल फॉलो. So I am removing all this minus sign which I have written over here. So we can say that you will get the same relation, right? So this ends the solution. One more thing I told you in the start of the video, that I will be talking about why differentiation method is wrong. Now some of the students in the exam, what they did, they wrote this relation n minus 1 into 2 by r, which I had written over here. Yeah. And they differentiated. They differentiated this ki delta f upon f square negative is equals to, when you differentiate this, delta n into 2 by r. Okay. Now this is wrong. Why is this wrong? Because this would have been correct if we were using the same n for whole lens. For example, अगर question ये होता कि this is the lens made up of refractive index n. Now we are changing the value of n by delta n. So what will be changing the focal length? Then this was right. But remember, we are changing the value of delta n only for the right half, not for the full lengths. So this n remains the same and only this n is changes. So you cannot do this. ये कब करते अगर पूरे लेंस का n slightly delta n change होता, तब ये करते. So I hope you would have understood, guys. I hope you would have enjoyed the solution. I was trying to, discuss about every possible case or every possible scenario that I could think of. Thank you.